Today, we will learn the first part of the Pontoon houseboat automation system. We will learn how to program the WeMos D1 Mini and D1 R2 to work with Alexa and an 8-channel relay, without any third-party app like Synric, Blink, or Google.
Hi everyone, thank you for tuning into Building from Scratch. As you probably know by now, my name is Richard. And we're going to start going into the automation of the Pontoon houseboat, starting with the, let me see if I can find it here, the D1 Mini and the D1 R2. We're going to go a little more into detail about those as we go into the video, but I want to let you know this is going to be a part one of a 6-part series on how to automate with Alexa with no third-party apps like Blink, Synric, or Google. And what we're going to be covering is we have a bunch of stuff here. Let me show you what we're going to be using during this series. Now in this series we're going to be doing some liquid crystal displays, some OLEDs, as I said, the D1 R2, the D1 Mini. We're going to be using a I2C multiplexer, a temperature sensor. Actually, we're going to be doing 2 temperature sensors. We're going to be using an RF to run remote switches for the lighting. I can't get to focus in on it. A ESP32S. This is the development board. There are 2 different ones. There's a 30 pin. This one is the 38 pin. We also have a sonic sensor. This is a water proof one. I am going to be getting another one. I'm not real happy with the performance on these. They're accurate. The problem is that the measuring distance, which we will get into later. And there is one more thing we're going to be adding to this. Let me see if I can find the picture. Now, we've ordered this. This is the MCP 20, let me double check. I think it's a 28017. Nope, it's a 23017. Now what this is, can't get my left and my right straight. Anyhow, what this is a GPIO expander. And basically, because of this project that I'm working on for the houseboat, I have 16 pins. Actually, there's 32 pins on this. On my EPS32S. And because of everything you're going to see put on this thing, I'm going to need some more IOs, and this is going to help me for all my relays. So let's go ahead and get Joey to work explaining exactly what we're doing on in this part of the series, and I will talk to you guys later. You guys have a great day. See ya.
As Richard said, today we are going to cover programming and using the ESP8266 D1 Mini and D1 R2 with Alexa and an 8-channel relay, without any third-party apps like Synric, Blink, or Google. This program can also be used with the ESP32S, but we will be covering that in another video. First, let's get to know the boards we will be using today. The D1 Mini is a mini-node MCU Lua Wi-Fi board based on the ESP8266. The D1 Mini Valon Wi-Fi Internet Development Board based on ESP8266 for Arduino, WeMos D1 Mini, MicroPython, Node MCU. The Valon board comes with 11 digital input/output pins, 4 M bytes, all pins have interrupt, PWM, I2C, 1 wire and a micro USB port. This Wi-Fi development board is used for Arduino IDE as programming, and support OTA Online. D1 Mini Development Board, you can use it to create wonderful and interesting things. Links to everything we are doing here are posted in the description below. The first thing we need to do if you have not done so already is to install Arduino IDE. Go to this address, arduino.cc. In here you see the software button. Click on it. This page will open, scroll down to your operating system. I am using Windows and I downloaded this one as it is a self-installer. Click your OS and this page will open, giving you the choice to either just download or contribute and download. This is freeware and I use it all the time, so I contributed $10. Once you download your version, open and install it. Now let's get the driver you are going to need. Go to this site here and download the CH340 driver communication driver. Now that you have that driver, install it. When installing it, you may get an error. Just click the uninstall button. Then click the install. You're doing great. Now open Device Manager, and open and look at your port. Plug in your D1 Mini or D1 R2. You will see a new port appear. Write it down as you will need to know it soon. Now open Arduino. Click on Files, Preferences, and you will see this spot here that says Additional Boards Manager. In that box, you can either type or click the link below and copy the link into this box. Close the box. Click Tools, go to Boards, and click on Boards Manager. This box will pop up. In the search box, type ESP8266. This should show up, ESP8266 Community. Install. Close the board manager and click Tools again, and go to Boards. Now you will see a directory called ESP8266 Boards. Go there, find your board, and click on it. I just used this one here for both the D1 Mini and the D1 R2. Next, click on Tools again and go down to where it says Port. Select the port you found in your device manager. We are now ready to program it with the blink test. I do this with every board that I install to make sure it is working right before I do my other programming. The blink test. If you have not done so, open Arduino. Click on File, go to Examples. Scan down to ESP8266. In the column that opens, click on the blink. This sketch will open. Just to make sure everything is copacetic, click this. It will compile the program and look for errors. Once it is done, you should see this. It is telling you everything is good. Now click this button to upload the program. Once it is uploaded, you should see this LED flash once every second. If so, it is time to program your ESP8266 to work with Alexa. The first thing we are going to need is this library, ESP Alexa. Click on the link below, and this page will open. Click on this tab here where it says, Code. It will open and click the download zip. Save it somewhere that you can find it. In your documents, you should have a directory called Arduino. What we did was made a directory called zip libraries to store all of the libraries we downloaded. This makes it easy to find. Once you have downloaded this library, go back to Arduino and click Sketch. Go to Include Library, add Zip Library. A window will open. Navigate to where you saved the file and click on it. Arduino will install the library. Now click on this link for the code. Right-click the ENO file and click Save As. Find a place to save it. Again, what we did, we made a directory called Sketches and saved them there. Basically, this is all you should need. Let's go through the code here so you know what to do if you decide to modify it like I did. Here you can see that the sketch checks if you are using an ESP8266 or an ESP32. Next, it's set the callback. At this point it is just set for 4 switches. For the ESP8266, you can have up to 10 devices. Here we name the relays for each of the callbacks, and we designate the PO pin the relay will work off of. Here you put in the SSID name of your Wi-Fi and your password for it. This is setting the ESP Alexa variable. Here we are setting the serial baud rate. We like to use 115,200. Now this is where we are telling the microprocessor to set out pins as output. This is checking if there is a Wi-Fi connection. If so, when the loop is run, it will tell Alexa that these names are connected with these callbacks. The name can be changed to whatever you want. And as I said before, you can add up to 10 devices. This tells ESP Alexa to begin, and if not connect, you get a message on your serial print. This is the loop function I was talking about earlier. I want to note that here, the sketch had the delay set as 1. We made it 10 because 1 made the loop run so fast, you would get lucky if Alexa found 4 devices, if any. If the sketch has the loop running a delay of 1, you should add a 0 to the end. Okay, here is the callback function that links the callback name with the action. Each callback is the same except the callback name, and the relay it turns on and off. For an example of what we are talking about with adding in name changes, this is my modified sketch. Here we have added 4 more devices, and you can see, we changed the names of the callback to help remember which one was for what relays. You can see that we added 4 relays with the PO pin they will operate. We changed the SSID and password. We added the output pins. We added devices here and gave them new names. You will notice we matched the callback names with the device names. This is the loop that I changed from a delay of 1 to a delay of 10. Now the last part. Look close at the callback function. We make a few changes. The callback name matches the name in the serial print line. Also, if you look, we reverse the digital writes. That is because, when the signal is low, there is the power to turn the switch on, and high, there is no power. This turns the relay off. Now let's look at it in action. First, I am sorry about the focus on this camera. After programming the microprocessor is done, wait about 5 minutes for the information to get uploaded to the Amazon cloud. Remember that you must have Wi-Fi for this to work. From there, go to your devices in your Alexa app. In the top right corner, you will see a plus sign. Tap on it. Tap on the Add device. Scroll to the bottom and tap where it says Other. Click on it. Now click the Add devices. It will take about 45 seconds for it to search. It is now showing that it found 8 new devices, all from the ENO file you will be downloading, naming lights 1 to 8. Here we have wired an 8-channel relay to a WeMos 8266 D1 Mini. We are using the 5-volt power on the chip to power the relay. Unfortunately, we blew one of the relays out. You can see the relays go off and on from the app, and it works just as well with the Alexa dock.